The nature of time has been a subject of philosophical contemplation and scientific inquiry for centuries, transcending disciplinary boundaries and captivating the minds of scholars, physicists, and philosophers alike. The question of whether time is real or merely an illusion is deeply rooted in the fabric of human understanding, probing the very essence of existence and reality. As we delve into this intricate exploration, it is essential to navigate the realms of philosophy, physics, psychology, and metaphysics to unravel the enigma that time presents to our consciousness. Please support us by subscribing to our YouTube channel. Your support makes a big difference. Philosophical perspectives. In the realm of philosophy, time has been a recurrent theme that has spurred profound reflections on the nature of reality. Ancient Greek philosophers, such as Parmenides and Heraclitus, offered contrasting views on the nature of time. Parmenides posited that change and multiplicity are illusory, suggesting a timeless and unchanging reality. On the other hand, Heraclitus embraced the notion of perpetual change, famously stating that you cannot step into the same river twice. These early philosophical musings set the stage for centuries of contemplation on the nature of time and its relationship to existence. Existentialist philosophers like Jean-Paul Sartre grappled with the human experience of time, arguing that time is intimately linked to human consciousness. Sartre's concept of temporality suggests that time is not an external, objective reality but rather a subjective experience rooted in human consciousness. The existentialist perspective introduces the idea that our perception of time is inherently tied to our existence and the choices we make. Temporal mechanics in physics. In the realm of physics, the nature of time takes on a different dimension. Albert Einstein's theory of relativity revolutionized our understanding of space and time, presenting a conceptual framework where time is not an absolute, immutable entity. Instead, it is a dynamic and malleable dimension that is intricately linked to space. The theory introduces the notion of space-time, a unified fabric where space and time are interwoven, and their properties are influenced by gravity and motion. Special relativity, formulated by Einstein in 1905, posits that time is relative and can dilate or contract depending on the observer's motion relative to the observed object. This phenomenon, known as time dilation, has been experimentally confirmed and is a fundamental aspect of our understanding of the universe. General relativity, developed by Einstein in 1915, extends these ideas to include the influence of gravity on the fabric of space-time, suggesting that massive objects can warp and distort the flow of time. Quantum mechanics, the fundamental theory governing the microscopic realm, introduces additional layers of complexity to the nature of time. The concept of superposition, where particles exist in multiple states simultaneously, challenges our classical intuitions about the progression of time. Moreover, the notion of entanglement, where particles become correlated in ways that defy classical causality, raises intriguing questions about the nature of temporal order at the quantum level. Psychological perception of time. The subjective experience of time, as perceived by individuals, adds another layer to the intricate tapestry of temporal understanding. Psychologists have long been intrigued by the variability of time perception and how it is influenced by factors such as attention, emotion, and age. Psychological studies indicate that time perception is not uniform and can be altered by cognitive processes. The phenomenon of time dilation, as reported by individuals in high-stress situations, exemplifies the malleability of our subjective experience of time. Similarly, the "time flies when you're having fun" adage captures the idea that our emotional states can significantly impact our perception of the passage of time. Cognitive neuroscience delves into the neural mechanisms underlying time perception. The brain's internal clock, often associated with the cerebellum, plays a crucial role in processing temporal information. Studies have shown that alterations in neural activity, whether due to neurological conditions or external factors, can distort the perception of time. Metaphysical considerations. Beyond the realms of philosophy and science, the question of whether time is real or illusory carries metaphysical implications that transcend the boundaries of empirical inquiry. Eastern philosophical traditions, such as Buddhism, offer perspectives on time that challenge the Western conceptualization of a linear, progressive timeline. The Buddhist concept of impermanence, or anicca, posits that all phenomena, including time, are in a constant state of flux and transience. From this perspective, the very notion of a fixed and enduring time becomes illusory, as everything is subject to change and impermanence. The idea of cyclical time, prevalent in some Eastern and indigenous cosmologies, contrasts with the linear model of time embedded in many Western traditions. In these perspectives, time is envisioned as a recurring cycle of creation, destruction, and renewal, transcending a linear progression. Temporal paradoxes and philosophical conundrums. The exploration of the reality of time leads to the consideration of various paradoxes and conundrums that have puzzled both philosophers and physicists. The classic thought experiment known as the twin paradox illustrates the effects of time dilation as one twin embarks on a journey through space at relativistic speeds, returning to find the other aged more rapidly. This paradox challenges our intuitive understanding of time as an absolute and uniform entity. Philosophical conundrums, such as the arrow of time problem, delve into the asymmetry of time's perceived directionality. Why does time seem to flow in one direction, from past to present to future, rather than existing in a timeless and reversible state? The irreversibility of certain physical processes, such as the increase of entropy in closed systems, contributes to this asymmetry and raises profound questions about the fundamental nature of time. The quantum nature of consciousness and time. Bringing together the realms of quantum mechanics and consciousness adds a layer of complexity to the discourse on the reality of time. Some theories propose a quantum basis for consciousness, suggesting that the nature of time may be intrinsically tied to the nature of conscious observation. The observer effect in quantum mechanics postulates that the act of observation itself can influence the behavior of quantum systems. This leads to the intriguing proposition that consciousness plays a fundamental role in the nature of reality, including the flow of time. If consciousness is intricately linked to the unfolding of events, it raises questions about the underlying nature of the temporal dimension. Overall, in contemplating the nature of time, we find ourselves at the intersection of diverse disciplines, from philosophy and physics to psychology and metaphysics. The question of whether time is real or an illusion transcends mere intellectual curiosity. It beckons us to confront the very fabric of reality and our place within it. From the relativistic insights of Einstein to the existential reflections of philosophers like Sartre, the discourse on time reveals a multifaceted tapestry where scientific empiricism and subjective experience converge and diverge. The enigma of time persists, inviting us to ponder the profound interplay between our consciousness, the physical universe, and the timeless mysteries that lie beyond our current understanding. Ultimately, the reality or illusion of time may prove to be a nuanced and evolving concept, subject to refinement and re-evaluation as our knowledge deepens. As we navigate the currents of temporal inquiry, we are compelled to embrace the uncertainty and richness of the journey, acknowledging that the nature of time may forever elude a definitive and comprehensive explanation. Please hit the like button if you know something new today, and share this video to your friends and family in case you think that this video has some interesting information. And support us by subscribe to this channel and hit bell icon to get more videos. Thank you and see you in the next video. Have a great day.